On to objective 2. So objective 2, we want to find the slope from the equation of a line. The slope is the same number as the coefficient of x in a given equation. So if you are given the equation y is equal to 2x plus 3, the slope is 2. The slope is just whatever the coefficient is in front of x, as long as your equation is solved for y. So if you have 1y, or just y, is equal to some equation, whatever the coefficient in front of x is, that is your slope. If you don't have 1y equal to something else, you need to simplify until you have y is equal to something to identify that coefficient. So in finding the slope of a line from its equation, you, step 1, solve the equation for y, and then you, step 2, the slope is given by the coefficient of x. So as long as you have something in the form of, and you may have heard this before, y is equal to mx plus b, where m is your slope and b is just a constant. So when you have your equation in this form, m is your slope. Objective 3. We're going to use slope to determine whether two lines are parallel, perpendicular, or neither. Two lines are going to be parallel if they never intersect on a plane. These are going to look like lines like this. They never intersect. Non-vertical parallel lines are lines that have the same slope. So we're saying it's not, as long as they're not vertical, then they have the same slope. So parallel lines have the same slope. Two lines are perpendicular if they appear to intersect at a 90-degree angle. This would look something like this. And we see here we have kind of this 90-degree angle in between. So two lines are perpendicular if they appear to intersect at a 90-degree angle, and the product of their slopes, or the two non-vertical perpendicular lines, is always -1. So this means that if we find slopes and we want to determine if they're perpendicular, we multiply their slopes together, and if they're equal to -1, then this means that those lines are perpendicular. If not, then they're just neither. So this means that these slopes are opposites, and one has to be negative. And we call them negative reciprocals. Remember, our reciprocal, if we're dealing with a fraction, would be we would flip our numerator and our denominator, or if we have a whole number, we would put 1 over that number. But now instead of just the reciprocal, we're adding the negative reciprocal. So we need to add that negative on there now as well. Example 2. We're going to decide whether the pair of lines is parallel, perpendicular, or neither. So we have two equations here. We're going to say x plus 3y is equal to 5. This is going to be equation 1. And -3x plus y is equal to 3 is going to be equation 2. So now what we want to do here is we want to determine their slope, and then we want to graph them and just make sure. We're actually going to scoot this over a bit. It is very close. And that should be good. So all right, dealing with equation 1, we want to find this slope here. Equation 1. We have x plus 3y is equal to 5. And now we'll find our slope if we solve for y. So let's go ahead and solve for y. So we solve for y. So let's subtract x from both sides. So we get x plus 3y minus x is equal to 5 minus x. This instead now is going to give us 3y. And instead of writing 5 minus x, I'm going to write -x plus 5. I can rewrite this in this way, since saying 5 minus x is like saying 5 plus negative x. And then once we're adding, we just use our commutative property. So we rewrite this to say 3y is equal to negative x plus 5. And now we just want to divide. If we're dividing 3y by 3, we also need to divide negative x and 5 as well. So we're going to divide each term by 3. And this is going to give us y is equal to now negative 1/3 x plus 5/3. So that's one equation. And since we have this equation and we have our coefficient in front of x, we see here that our slope, or m, is equal to negative 1/3. And now we want to check the slope of our second equation. So equation 2, which is negative 3x plus y equals 3, we want to, once again, solve for y. And if we're solving for y in this case, we want to isolate y, so let's add 3x to both sides. Say negative 3x plus y plus 3x is equal to 3 plus 3x. So now we just have y is equal to, and once again, I'm going to reverse it using our commutative property of addition to just say 3x plus 3. So now we've solved for y in this case as well, and our slope is equal to 3. So the first thing we realize is that our slope is not the same. So we can say here, our slope is not equal, so it must be perpendicular or neither. Neither. I just forgot how to spell neither. All right, so it must be perpendicular or neither. We know it's perpendicular if we multiply them together and they equal negative 1. So let's multiply our slopes to see if they equal negative 1, and this would mean that it's perpendicular. So we have negative 1/3 times 3. That would become negative 3/3, which is negative 1. So our pairs of lines are perpendicular. Our pairs of lines are perpendicular. And now let's just graph them to really see what this looks like. So using y is equal to 3x plus 3, with our equation 2 here, if we plug in 0 for y, we're going to get that x as negative 1. So our x-intercept is negative 1, 0. Sorry, negative 1, 0. If we plug in 0 for x in this case, we would get y equals 3. So our y-intercept is going to be 0, 3. Get negative 1, 0, and 0, positive 3. And we'll draw our line here. Looks something like this. Oh, come on. There we go. And that is a little, slightly bit off. And let's extend it a little bit out here. So something like that. Then equation 1, we have y is equal to negative 1/3 x. So if we solve for our x-intercept in this case, it will actually give us 5, 0, which is coincidentally this value here. So for equation 1, our x-intercept is 5, 0. And our y-intercept in this case is going to be 5/3 or 0, 5/3. 5/3 is technically 1 2/3, so we're really just going to estimate this spot on our graph. And let's say it's about right here. And that's not the right color. Right about here. And this we're saying is 0 and 5/3. And we can draw this line here as well. So it looks something like this. And let's extend it just a bit. And so we see here that we do have intersecting lines, but the key factor is that it does appear that we can draw 90-degree angles. So we do have perpendicular lines. And the main telling point that we have perpendicular lines is that when we multiply our slopes together, we do end up with -1. You don't necessarily have to graph either of these lines in order to see that they are perpendicular or parallel, or neither for that matter. We just graph them so we can kind of get a visual of what they looked like as well. So you don't necessarily have to graph these problems every time you run into them. Last objective here we had that we want to solve problems involving average rate of change. So the slope formula applied to any 2 points on a line gives the average rate of change in y per unit change in x, where the value of y depends on x. So a little bit of a confusing statement. Our average rate of change is actually just kind of the applied way of saying slope. Average rate of change is just the slope. You find it the same way that you would find slope. We just call it the average rate of change when we want to give more of these kind of applied problems. So we want to solve the following problem. The graph in figure 32 here, which is our graph that we're given, approximates the number of digital cable TV customers in the United States during the years 2006 through 2015. Find the average rate of change in number of customers per year. We're just finding the slope between two lines. So zooming in a bit here, we can identify we are just finding the slope between 2 points. If I said lines a moment ago, I apologize. We're finding the slope between 2 points. And our 2 points in this case are 2006, 33 and 2015, 53. So let's say our x1, y1 is 2006, 33, and our x2, y2 is 2015, 53. So we found our 2 points, and we want to use our formula for slope. And our formula for slope, we determined m was equal to y2 minus y1 divided by x2 minus x1. Y2 we determined is 53, y1 is 33. Then we see our x2 is 2015 and our x1 is 2006. So solving this, 53 minus 33 is just going to be 20. And 2015 minus 2006 is going to be 9. Now in fraction form, 20 divided by 9 is in its simplest form. But we want to find the average rate of change in numbers of customers per year. So in the context of the question, it'd be better to give a decimal. So we're going to say, if we calculate 20 divided by 9, this is going to be about 2.2. And since our slope is positive, this indicates an increase. So when we give our final answer, we say that the number of digital cable TV providers increased by 2.2 million, because we had our answers here in millions, or our customers in millions. So we say increased by 2.2 million customers per year on average, because remember this is our average rate of change. So increased by 2.2 million customers per year on average from 2006 to 2015. So when finding average rates of change, we just solve for our slope the same way as we would. We just call it something a little different, and we kind of try and translate it in a better way for the context of our problem. So all right, that finishes up section 3.3. I'll see you again in our next section.